I want to thank everybody that came out, and thank the Let's Fire Department for letting us use their facility here. If you are an amateur radio operator, we have a drawing back there. You can put your call sign in for a dual band HT. And if you're interested in becoming an amateur operator, we have some information back here, and one of our club members is sitting back there. And so we'll have the National Weather Service give us our training here this morning. And afterwards, go over and support the fire department at the fish drive.
All right, thank you. It's great to be here, and nice turnout. Thanks for coming out on your Saturday morning. You know, I'm waiting for spring. How many of you guys are ready for spring? Yeah. I mean, it hadn't even been that bad a winter, but it's just like, we're ready for spring. We're ready for everything here. So, my name is Sam Lashley, and I'm the warning coordination meteorologist with the National Weather Service Indianapolis office. I just took over that position in September, and I took over for Dave Tusek. Some of you may have seen Dave. It's been here in the past. Dave finally retired, and from what I understand, he's enjoying his time off and getting a little fishing in done here and there. And, I actually hope to see him here later this afternoon at a retirement dinner that we're having for our boss, who's actually retired from the Weather Service as well. So we're going to have a lot of changes at our office. Just a little bit of a background. I'm born and raised in Indiana. I grew up in Crawfordsville, and I worked at the Indianapolis office about 20 years ago. And then I had an opportunity to move up to the Northern Indiana office, and I was a senior forecaster up there for 20 years. And then this position came open, and it was just a chance to get back closer to home and to move up the ranks as well and do what I've always wanted to do, and that's be the warning coordination meteorologist and come out and do talks like that. So that's kind of my background and history. We've got a new show this year. We've changed things up. How many of you have taken training before? Okay, good number of you. So it's going to be a nice review for those of you who haven't. It's a good beginning. We try and mix things up between fresh and new. So you're going to hear a lot of refresher terms, but you're going to see hopefully new pictures, new video, things like that. So we're going to start out with a very short video that kind of gives you an idea of what NOAA, the National Oceanic and Atmospheric Administration, what we do as a whole agency. It's not just about the Weather Service. We do a lot of different things. So we'll start with that, and we'll get make sure everybody can hear in the back with the sound. You guys hear that in the back? Okay. Can you see that okay, or do we need to turn the lights off? Try. Is that a little better? Yeah. Okay. Promise not to go to sleep on it? in there, but there's a lot of different other aspects that we do across the whole United States, but also here. So you maybe saw the space weather thing. Amateur radio operators are familiar with space weather, right? All your disruptions. That's something that could impact all of us. If we have a big space weather event, a solar flare from the sun, that could disrupt communications, the power grid, and things like that. So we're working with power companies and Homeland Security and help preparing for those types of events. So today we're going to focus on the weather, and like I said, we're going to talk about a lot of different things, but most importantly, why being a spotter is important, why you're here today. And spotters play a critical role in our National Weather Service warning decisions. So a lot of, we're working with a lot of sociologists now, and they tell us that when we put a warning out, if we can put a credible report that a trained weather spotter has observed weather, a tornado, large hail, winds, if we can put that into the warning, people will take action quicker. If we just say radar indicated a possible tornado, the research has shown that people won't act. They'll turn on the TV, they'll maybe call somebody on the phone and see if they heard the same thing. They'll go to the window, look out the window, and it's not until they actually feel the threat that they will take action. And many times that's too late. Right. So you're going to be critical into helping us make people act and get to safety. Then the radar has its limitations. We'll talk about that here in a couple different spots in the show. But why we need you. We need eyes and ears out there telling us what you're seeing. Does that match what we're seeing from a building in Indianapolis looking at radar data? So here's an example. Here's our radar in Indianapolis. And as you go out from the radar, you see these different color range rings. And those correlate to the radar beam and how far above the ground they are. So as you get farther out, the radar beam gets higher and higher and higher in the sky. So when you get well outside to these outer rings, radar beams anywhere from 5 to 10,000 feet. So that's really much too high to get an idea of what's happening at the surface. So for other radars, we have nearby radars that we will use to fill in these gaps. So that helps us get kind of a three-dimensional picture of the storms and what's going on. So we will use all these different radars in conjunction with spotter reports to understand what these storms are doing. So your information helps make better informed warning decisions. We can look at this radar, we can put your reports together with that and get better warnings out, and I'll show you that in a second. Emergency managers can better allocate their resources. You know, if we can give them good, reliable information, we know that the next county over, what they're going to expect, and the next county over. So it's advanced lead time for the counties as you progress across with storms. And then we can help first responders get to those in need. We can take your reports and pinpoint where the damage is, feed that back to the emergency management. We even work with the media quite closely. They can relay that information to keep, hopefully, people off the roads, which is a big thing after storms, right? We don't want to see that. So we're all working together. It's a big partnership, and those spotter reports help make that very critical decisions work. So most importantly, your reports do help save lives, and we're going to talk about that even more in depth coming up. So a good spotter knows safety and preparedness. First and foremost, we don't want you putting yourselves in danger. Okay, we want those reports, but you have to stay safe. You have to know when to take cover. You have to know what the clouds are doing, what they look like, where to go, and when to go. We're going to talk about where to get your weather information, how to prepare from days in advance to hours to minutes. We kind of use a funnel approach there. Then we'll talk about how to identify storm features, the clouds, funnel clouds, shelf clouds, wall clouds, all those different kinds of cloud features that indicate different kinds of weather. And then we'll briefly talk about how to submit effective reports to the National Weather Service. So here's a great example. We go way back to 1999 of how spotters played a critical role in warning decisions. So this is from a forecaster at our office. He worked in the Cincinnati office years ago. And they were watching these storms. It's around 5 in the morning. And typically that's the lull in the atmosphere. We can get tornadoes in any hour of the day, any day of the year. But typically in that 2 a.m. to 7, 8 a.m., that's a pretty good lull. The atmosphere is just really not conducive to tornadoes. But they were following a storm, they had rotation on radar, and the last thing you want to do is issue a tornado warning at 5 in the morning, okay, for obvious reasons. But there was a spotter, a trained spotter that was up, and he happened to notice between the kind of the sun rising and the lightning strikes that he saw a developing funnel cloud and possible tornado. So he called the office. That lined up perfectly with this rotation. So the Weather Service office there went ahead and issued a tornado warning. That gave an additional 10 minutes of warning lead time for people to have their weather radios to go off, to get to their basements and to get to safety. Here's what happened. It turned out to be a very significant F4 tornado that did quite a bit of damage. So eventually the Weather Service said we would have issued a warning because the circulation got even stronger, but that spotter report gave them an additional 10 minutes, additional confidence to put that warning out early. In 2018, here in Indiana, reports helped prevent a false alarm tornado warning from going out. So there was a little bit of rotation on radar. We're going to talk about this coming up, how to look at radar and see rotation. But trained spotters were actually sending in via social media pictures of a wall cloud, rotation. But there was a rain shaft, but there was no physical funnel cloud or tornado, indication of a tornado. So they were telling us this. So the Weather Service was holding on, not issuing a warning, because we don't want to put all these false alarms out and then people not react when they need to. So again, there's a little close-up of the pictures. Here's another view. You can see a storm. This was a rotating updraft. We'll talk about that. But there was nothing going on below the base of this. All the elevation was elevated. So the Weather Service did not issue a tornado warning, and a tornado never occurred. So quality, timely reports can help us get warnings out, but it can help us from not over-warning. And here's a great example. You know, this is a wall cloud, that distinct lowering. And you might say, oh, there's got to be a tornado. Look, it goes behind that tree. Don't assume anything's going on if you can't see it, because in this case, nothing happened. I worked an event in northern Indiana a few years ago where some young spotters were calling in tornado heading towards Wabash, Indiana, and we were issuing tornado warnings because we had a circulation. Storm moved through Wabash, no reports of damage, nothing. Yet we had trained spotters telling us there was a tornado going through the city. Turned out, we got pictures from them the next day, and all their pictures, there were trees like this. It looked like something was coming down, but that funnel cloud never actually made it down to the ground. So don't make assumptions, call it in, but tell us, I can't see because there's trees, I can't tell if it's on the ground. Don't hesitate to tell us you're uncertain, because that will help us. So as we move on here, we're going to talk about hail, how to identify different sizes of hail, flooding, what to report, straight line winds and wind damage, funnel clouds, and tornadoes, obviously. So we got a lot to cover here. When reporting hail, we want you to try and match it up with objects that are pretty uniform in size that everybody's familiar with. So our severe thunderstorm warnings start out with a quarter, which is diameter is 1 inch. So a quarter makes a real nice item to use when you call it in. Anything below that, we have dimes and nickels. We've always kind of said not to use marbles because in the past, marbles, there was, you know, when everybody was young, you had different sized marbles. Well, honestly now, I kind of collect marbles. I'm kind of a weird geek, I guess. My grandmother taught me aggravation. How many of you remember aggravation? Marble game? Okay. I made my own board. That's how much of a geek I am. But now when you go to stores, marbles are all about the same size. They're about half inch. So I say as long as you're calling in the normal size marble, that's about a ½ inch. But really, when you start getting above quarter, that's the important things. And you can see we have ping pong size ball, golf balls 1 3/4 inch, tennis, baseball, and then grapefruit and softball size hail. We have had instances of grapefruit and softball size hail in Indiana. It doesn't occur a lot, but maybe every couple years. So be ready for that, and it's pretty impressive, and you don't want to be outside when that larger hail falls, and I'm going to show you why. So when measuring, you want to find the largest stone, and make sure the hail ends before you go out and pick up those hailstones. But you want to measure, don't laugh, I'm going to show you a video. You want to measure the the longest diameter of the hailstone. It won't be perfectly smooth. It will have jagged edges. And we would just want to know the largest size. So I promised I was going to show you video. This is how you would go out if it is still hailing and measure hail. So if you can't tell, he's got a pail on his head. He's being safe. And of course, his wife is making fun of him and laughing there.
Get in the house, Rory.
Telling her son to get in the house.
We don't have golf balls around here, buddy.
So, he was actually a meteorologist. Him and his family were out visiting family in Montana, and they had this big hailstorm, so they had golf ball sized hail. So just be careful. Most people, you know, you're not going to die from hail for the most part, but if you do get hit in the head, you can be seriously injured or potentially die. All right, moving on to flooding. We want to know anytime significant flooding's happening, but when you get heavy rain, you know, the drains just can't handle it. You're going to get street flooding, and we really don't need to know about your typical street flooding. We want to know about more significant. When you see this flooding that you've really never seen, or it's been 10 or 15 years since you've seen the streets around the area flood. We want to know that. We want to know when there's flash flooding. That's a flash flood there. When culverts are going to be washed out, when people's lives are going to be put in danger, that's flash flooding. So the water's going to come up rapidly, it's going to overwhelm the infrastructure, and you're going to have all kinds of problems. And then river flooding, this is more of a long duration event, but when the river starts to get into levels we haven't seen in a while, and buildings or roads are starting to be affected, we want to know about that because we can keep track of that for future events to let people know when we think that river is going to get to a certain level, we know exactly what roads and buildings are going to be impacted by it. Any kind of wind damage that you see, we want reported in. Obviously, you know, large trees down, but anytime there's also buildings, you know, just any kind of infrastructure that you see damage, please call that in, even if it's after the fact, because we verify all of our warnings. We're scientists, we're trying to get better, so we keep very detailed statistics on how many of our warnings verify, what our lead time is between when we issued the warning and when the first damage occurred. And then we go back and we try and learn from this. We even have what's called a weather event simulator. You know, pilots have their simulators they train on. We actually have a training computer where we can play back events from anywhere in the country, and we sit there and actually monitor the data and issue practice warnings. And having these reports of damage then helps us understand when we should have issued a warning and not. So we're constantly training. So it's very important to get that information to us. Obviously uprooted trees, big trees down, but loss of bigger tree limbs. We don't need to know, you know, you got little twigs falling off, that's okay. But just larger tree limbs coming down, trees being snapped, anytime power lines come down, buildings being overturned, substantial loss of shingle, etc. You know, things out of the ordinary we want to know about. Where do you report? 1-800-499-2133 is our spotter line. So in the back, and I didn't mention this, there is a sign-in sheet. If you haven't done that, do that at the break or before you leave today. But there's also some handouts back there. If you have your smartphones towards the end, I'm going to show you some websites. We have the little QR codes that you can just scan with your phone with the camera, and it'll pop up on your phone, the websites. But that's also on the handout in the back. We're on social media, so you can follow us at NWS Indianapolis. We're on Twitter, Facebook. There's different hashtags for whether if you do that on social media. I'm sure you're probably already following us. And then amateur radio, if you're amateur radio operators, we don't always bring someone into our office like we used to, because with the internet and social media, we can actually do it more efficiently now. But we always do start up a net and have a group that are monitoring from home, and they relay to us via some chat software that we have now. Now, if it looks like it's going to be a big event, yeah, we will bring them in, so we've got that backup communications in our office. Who, what, when, where, keep that in mind, the standard things. Just always keep in mind if it's a delayed report, you know, maybe you saw a tree down and you waited a half hour, an hour, or several hours to call it in, make sure you let us know that, because we try and match your report up with radar, and if they don't make sense, then it kind of confuses us. We're easily confused sometimes, okay? Especially on mornings before coffee. But we do unfortunately have people that call in false reports. I don't know why, but we have to distinguish between that and true accredited reports. So in summary, like I said, you're a trained eyes and ears in the field, you're helping emergency manager, and you will help save lives. Now don't get excited, we're not done yet. Okay, that's just the first section. Okay. Okay, resource and products. Where can you get more information leading up to weather events? Well, weather.gov/IND. That's your National Weather Service page. All kinds of good information, web briefings, weather story we put out daily, hazardous weather outlook we're going to talk about more in depth. That's going to be your main place to get information. We're going to get a new radar display on our website, and that's a pretty terrible display, to be quite honest with you. It's very, very old. That's coming, I'm told, here later this year. If you have a smartphone, our biggest question we get, people say, what's your app? Do you have an app? We don't have an app. Private sector, they make the app so they can make money and they don't want the government competing. We get that. So what we have is this website, but you can save this on your smartphone home screen and it will look and act like an app. So mobile.weather.gov, you can get forecasts from anywhere in the country. You just put in a zip code or the city name. You'll get current conditions, you'll get a detailed forecast, and you also get some other items there. Forecast discussion is kind of a behind-the-scenes product we put out that tells you why we made the decisions we did and the forecast we put out. So it's a little bit geeky and scientific, but if you kind of like that kind of stuff, check out the forecast discussion. We get a lot of positive comments from people that like that. So the hazardous weather outlook, this is the text product. So it just tells you today and tonight, any hazards we're expecting, but then for the next days 2 through 7, what we think might be important or critical. So in this period, for the last few days, we've been talking about this potential for a heavy rain threat that's coming up early next week. But now that looks like it's shifting off to the south. So we're still going to get rain, but it doesn't look like we're going to get the substantial rain that might have caused more significant flooding. So we're still watching that in case there's any changes. This gets updated twice a day, once in the morning and once in the afternoon. And then if things really change, it will be updated even more frequently. So that's going to be a great place to just constantly kind of monitor every day. Okay, what do we have coming down the road that we need to worry about? Well, now we're moving into the 21st century finally, and this is going to be graphically oriented. So now you can kind of see our different hazards here. So if we were worried about excessive rainfall on Friday, this turns yellow. If it were very significant, this might be an orange or a red. But if you're green, we're not worried about it. If you're yellow, there's a little bit of a concern. But if you click on any one of these little chiclets then, it will open up a window for central Indiana and show you that we have here, we have a limited threat to the west, we have no threat to the east, but then there's elevated, significant, and extreme. You want to check this daily because as we start from the day 6 or 7, as we get closer to the time of the event occurring, we're going to be able to narrow down and have more confidence. So these elevated levels will likely increase if the event looks like it's going to happen. So sometimes people say, well, I looked at the forecast 4 days ago and you guys didn't say anything about this. Guess what? It's a science, it changes, okay? So you need to be aware of that and constantly check the forecast, especially if you have outdoor events. Now when you have fish fries, and I'm in town, I try and bring nice sunny weather for you, okay? So, now if you've done this tomorrow, it'd be really nice. It's gonna be a lot warmer tomorrow.
Yeah.
But take what you can get in February, right? All right, the Storm Prediction Center, spc.noaa.gov. That's just if you want more information about watches that are going to be issued or potential areas of the country where severe weather may be possible. Storm Prediction Center monitors that. They are the ones that actually put out the watches for our area. So they call us, they coordinate with us, and then we decide where the watch is going to be. So we're going to show you a video here, kind of how that process works from the Storm Prediction Center.
Severe weather can develop quickly. Advances in forecasting allow the NOAA National Weather Service to predict severe weather before there's even a cloud in the sky. Severe thunderstorm and tornado watches give you advance notice that conditions are favorable for dangerous weather. When your area is in a watch, be sure to stay alert for changing weather. Remember, a watch is not a warning. A warning is only issued when severe weather is about to strike. The NOAA Storm Prediction Center in Norman, Oklahoma, monitors weather conditions across the United States. They issue daily forecasts showing areas of the country that are likely to experience severe weather. In the hours before storms form, the Storm Prediction Center discusses the weather with National Weather Service forecast officers within the areas at risk. The Storm Prediction Center then issues a watch to notify people in those areas to stay alert for severe weather. A watch also includes information about what type of weather you might see and the chances of it actually occurring. The risk level can range from a few storms with hail and high winds to a particularly dangerous situation when deadly tornadoes could occur. The most important thing you can do when a watch is issued is to stay alert for developing storms and understand your risk. Be sure to tune in to your local news for updated weather information. You can also get instant weather alerts from NOAA Weather Radio. Watches also provide an opportunity to review your family emergency plan as well as check your disaster supplies kit. When the risk increases and severe weather moves in, you'll be ready if a warning is issued. If you need help developing a plan for your family or packing a kit, check out ready.gov for all the information. Stay alert and stay safe this storm season.
Okay, so obviously you saw a weather radio there. Hopefully everybody has a weather radio. If you don't, strongly recommend you get that. But we talked about the outlook, days in advance. Now we've got your watch, so we're within a few hours of something happening. So the way I like to explain this is, think about you're going to boil a pot of water. Okay, so you fill a pan with water and you put it on the stove. That's sort of the outlook phase, right? I know I'm going to boil this. I'm just not sure when I'm going to add the heat and when it's going to actually boil. So you're preparing. Then we turn the stove on. We turn the heat on. That's the watch phase. Okay, now I've added the heat. Now we know it's going to boil here very soon. So now we need to be ready for that. Then the warning phase is right when you start to see those bubbles start to come up. Okay, it's just about ready to boil. If everything works right, we can get a warning out right before the boiling starts, so you have time to prepare for it. So the atmosphere kind of works in a similar progression. So after a watch, we're monitoring the situation, we get spotter reports, we will issue the warning. So a severe thunderstorm warning occurs when wind gusts of 58 miles per hour or higher are going to occur. Now, as winds get up above about 60 miles per hour, for every 1 mile per hour increase in wind speed, the amount of damage goes up much greater. It's more exponential. So wind speeds increase like this, damage increases like this. So especially once you get up to 70 miles per hour and greater, it's a significant amount of damage that starts to occur, much greater amount. So that's why we kind of are working towards possibly having maybe a tiered warning system here down the road where we can indicate those higher end wind events. It's very difficult to do as a meteorologist, but we think we're getting there with the technology. Hail 1 inch in diameter, that's when you start to see damage occur from hail, siding damage, roof damage, crop damage, that kind of thing. Then the tornado warning, anytime we see rotation on radar and we think that rotation will make it down to the ground, or confirmed reports of a funnel cloud or a tornado will lead to that tornado warning. Then flash flooding, just 6 inches or more of flowing water over a road will float most vehicles. And if you get up to 12 to 15 inches of flowing water, that will take away most bigger vehicles, including school buses. There's unfortunately been several school bus incidents driving through flooded roads recently. If you want to be scared to see the power of water, get on YouTube or just Google flooding in school buses and watch some of the things that happen. So it doesn't take a lot. And then you don't know if that water's washed away the road, which I'm going to show you some video of what happens when that water gets up high and you can't see what's under. So storm safety, like I said earlier, this is the most important thing. You want to make sure you're sheltered in a sturdy building. You want to be away from windows, on the lowest floor, interior room or closet. So here, for example, through the door in here, the restrooms are a great place. No windows, a lot of walls protecting you. Open spans are not good places to be because there's no support and they will come down. So school auditoriums, gymnasiums, things like that are not good places to be. Even if you take shelter, you still want to cover your head with your hands. Take that pose because you will have flying debris if you take a direct hit. Mobile homes just are not safe. You want to be out of there well before severe weather strikes. So hopefully there's a safer building nearby that you can get to. If you live in a mobile home or know anyone in a mobile home, check on them. Really pay attention to the weather on these days. Then if you're in a vehicle and it's unfortunate, if the tornado, you can see it, it's far away. If you can drive at right angles from the tornado movement, that is best. Hopefully you're not in that situation. And then in a worst case situation, the tornado's right on you, what do? You need to abandon it and get into a ditch, a very low-lying area. The thought there is because the winds will be above you and any debris that's being picked up will be thrown around above you. You do have to be cognizant of heavy rain, the potential for that ditch to fill with water. But like I said, hopefully you never get there, and that would be an absolute last resort to do something like that. At night, it's very difficult to observe at night, especially tornadoes. Your eyes might play tricks on you with lightning, so you have to be very cognizant of what's going on. So we're going to play a little video here of what it's like. See if you can spot, that was always loud. See if you can spot a tornado. Anybody see it? See it yet? Did you see that one? So again, depending on how long that lightning strobe is, so there's a screen capture. So that was actually a very significant tornado that was occurring at night, and the spotters could only tell as that lightning would line it up. The other thing you can look for is power flashes. With tornadoes, when they hit power lines, a lot of times they'll rip it out, the transformers blow, you'll get that kind of blue light that flashes. That's kind of a telltale sign you probably have a tornado. The straight line winds, for some reason, just don't seem to rip it out and destroy it like a tornado does and create that blue flash. Lightning scares me more than anything. That's what I tell people. I do storm chasing. I was down in Henryville for the Henryville tornado, videotaped that. My biggest concern was being struck by lightning while I'm outside the vehicle, okay? That's why it's the #2 weather killer. The #1, flooding, is mainly because people drive through flooded areas and get themselves into trouble. Lightning, there's nothing you can do. If you're outside, you're vulnerable. There's absolutely no warning when a lightning's going to strike. So you want to be inside a building, preferably with plumbing or wiring, so the building's grounded. Anything with open walls like a concession stand, not going to be a good place because that lightning can still strike and get underneath and inside. An automobile is safe. The frame of the car will protect you. Just make sure if you're inside, you're not leaning on anything metal inside the car, but you'll be grounded and safe. So outdoors is just dangerous, and you can see the examples there of why. So pay attention here. It happens just that quick. Okay? It's not even raining. You might think you're safe. You're just sitting out there, and boom, all of a sudden out of nowhere, there's a lightning strike. Obviously, you don't want to be near tall objects, but that lightning bolt could hit anywhere. It's just attracted to those because they're there. But if you're standing clear over here, you could still be struck by lightning. Keep in mind there's other hazards. So if you are out driving around, you're looking at damage, or in this case, your storm chaser is looking for a tornado. stay fixated on what might be happening around you. There are other hazards. So in this case, it's probably not a good idea to pass a police car there on the right. Probably there for a reason. And these guys drive into this area of flooded road, so they say, okay, we're turning around, we're getting out of here. Oops. Unfortunately, they couldn't see the ditch that's full of the water, and they drove right off into the ditch, and basically the vehicle was, completely lost. They were fine, but I'm sure the officer in the police car got a good laugh out of it. Then he went to check on it. So just be aware. Don't do this. Okay, I told you about the 6 to 12 inches of flowing water, and here's somebody that I don't know what they were thinking drove into it. So you can see how quickly the wheels are off the ground. They are basically a boat with no propeller. They're at the mercy of wherever the water is going to take them. So this has a good ending. I should say a safe ending, not a good ending. But I let this play out because it's just pretty impressive what happens here. So fortunately, there's a pedestrian bridge you see coming up here, and the car actually gets stuck there by it. So now they would be in danger of the water rising, obviously, and creating further problems. But there was a good Samaritan kind of standing there on the bridge watching, and he starts to come from the top of the picture here. You'll see in just a second. There he is. So he's checking on the person. The water's rising. So the person in the car is yelling something at him. And obviously he becomes concerned enough that he starts to climb over to help. So now this person has put this person in danger. Not to mention the first responders that eventually will show up have been put in danger by these actions. But that bridge and that car could give away at any moment. You don't know what's going to happen. So again, it's almost done here, but you're trying to figure out what's he saying, what's he doing, and he reaches in and wait for it. This is the suspense of the show. What's going to happen? Can you tell what he took out? A baby, a toddler. Yeah, this person actually drove through that with a young child in the car. So, very fortunate they got out and they were safe. But this is why we preach turn around, don't drown. Okay, it was senseless. There was no need for these people's lives to be put in danger. If you're riding a bike, they say you never know what's under there. I just let this play for like 15, 20 seconds. It just keeps getting funnier and funnier and funnier. But this was actually a live shot. There was a TV crew setting up for a live. This was live on the air. Poor kid, but yeah. Okay. Yeah, exactly. Yeah. So for the young people, be careful when you ride your bike. All right, so now we're going to move on to the basic meteorology. I talked about the radar limitations. So we have the radar beam. Here, as it goes out, you can see it gets higher, higher, and higher. So we have two identical storms, one that's close to the radar. We're going to sample it pretty good. And the radar goes around, sends a beam out, and then it lifts up, and it sends another beam out, lifts up, sends another beam out. It does that several times, and then it comes back down and starts all over again. It takes about 4.5 minutes to do that. So we're constantly getting scans. But that lowest beam is always going to get higher because the Earth curves, and so that beam's just naturally going to get higher as it gets farther away from the radar. This is where spotters are important. We might be able to have a real good idea what's happening here. You're confirming it. But out here, we may be above the rotation. We may be above what shows up on radar for a hail core that might reach the ground. But your report's out here telling us, hey, I'm getting hail. And we're like, ooh, we must be overshooting that core. Helps us lead to that morning decision. So you're filling in those gaps for us. When you see on television, you see the radar image, the reds and the greens and everything. What does that mean? Well, it's called reflectivity. And it's called reflectivity because when the radar beam goes out and it hits a raindrop, the bigger the raindrop, the more energy it's going to reflect back. If it's a hailstone, obviously it's a harder substance, it's going to return even more energy back. So you start seeing these darker reds, and as I tell my friends, if you see purples and whites, that's bad. Okay, so just remember that purples and whites are bad on the radar. But it equates also to rainfall rate. So if this storm were to sit here for 1 hour and this red was right over you and it never moved, that would equate to about 4 inches of rain. But fortunately, for the most part, these storms are moving, so you only experience that rate for a very brief period as that storm moves across. It's called a Doppler radar because it also remembers which way those raindrops and hailstones were moving. And so we can see wind movements, and this is what we call a velocity product. So let's say over here, the radar is up here. The red is air moving away from the radar. The green is air moving towards the radar. So you get this broad rotation, but then you can see as you narrow down, you get brighter kind of oranges and blues. That's a very tight circulation. So that means the radar is seeing the storm circulating very quickly. Now that doesn't necessarily mean you have a tornado because we don't see the ground. Remember, we're high up, so we're relying on spotter reports. But this is the radar image from the Joplin, Missouri tornado several years ago, if you remember that. That's what it looked like after it moved through Joplin. The other thing we can see is with cold fronts, we can see the air converging along a cold front. That's where storms like to develop or are actually occurring. So we can tell how strong the winds are ahead and behind a line of thunderstorms with this product. And here's an example. We're going to talk about bow echoes and squall lines a little bit more in detail coming up. But when the winds from the top of the thunderstorm start to descend and come down, they're much stronger. So they actually start pushing the rain out. And so you get this bowing segment. That's where the name comes from. So the winds back here are much stronger than up here, so it starts pushing that rain out much faster. So the velocity tells us that the winds behind that are 80 to 90 knots, which are roughly 100 miles per hour. So you have that associated with this. Now, again, this is up above, but when we start to see these little notches behind the red, that means some of that air is actually pushing all the rain out of the way and getting closer to the surface. So that's why anytime you see these bowing segments on radar, if one of those are heading to you, it's just an advance heads up. You should really start to take cover and get inside. I'm sure you've all heard of hook echoes on television or previous trainings. That is when that circulation actually takes the rain and hail, and the whole storm's rotating, so it circulates that air around the tornado. So you get a comma or a hook signature. We'll talk about that more coming up as well. So what ingredients are needed to get these thunderstorms to develop? So for any thunderstorms, whether they're severe or not, you need warm, moist air at the surface, and you need much colder air aloft. You've probably always heard you need warm and cold air clashing to get tornadoes. Well, to some extent you do along the horizontal, but more vertically. The colder it is aloft, the warmer and more moist it is at the surface. That allows the air to really want to get rising and climbing and create these stronger thunderstorms. So one way you can tell if the air is warm and moist is by the dew point. So just an easy rule of thumb, if the dew point is in the 60s generally, you have enough fuel for the thunderstorms to develop. If you're in the upper 60s and especially in the 70s, you have high octane fuel for thunderstorms. Okay, that's what you want, is to look for those dew points. That moisture usually comes from the Gulf of Mexico, and that's kind of the number one thing we look at. Are we going to have that low level moisture? Because that is the fuel for the thunderstorms. So that creates an unstable air mass. But you can have those high dew points and not get thunderstorms, right? A hot, humid summer afternoon, you're sweating like crazy, but you're not getting thunderstorms. We need something to really force that air, something to get it going. And that's usually in the form of a cold front or a warm front or some kind of boundary that lifts that air. Now to get severe thunderstorms, we need wind shear. That's the critical difference here for the most part. So what is wind shear? Well, there's two different kinds. There's speed shear and directional. Speed is simply winds that increase with height. So here you have 5 miles per hour, 15, 20, 25, 55 miles per hour. So that speed increases as you go up. So this can lead to a squall line or a bow echo. because all the winds are the same direction, there's not a lot of turning going on, you're going to get those storms that just kind of move straight and accelerate. But if we add directional shear, winds that change as you go up, that's what gets the storms rotating. So when you combine the two, that's going to generate the big supercells, the hook echoes, and the large violent tornadoes. So that's what we're looking at as meteorologists, combining that with the moisture with the storms. The other thing wind shear does, it allows these storms to continue. So if you don't have wind shear, you get an updraft, and then it starts to rain, the rain falls through that updraft, and essentially cuts the storm off and the storm dies. So it can't really get going, it doesn't have time to develop. But when you add in wind shear, you separate that inflow from the downdraft, and now the storm can just continue. It can continue its fuel source coming in, and all the weather then starts to happen either downstream or backstream of the updraft. Here's a cross section. So if this storm was moving from your left to your right, you know, it's kind of a sunny day, storms start developing. We're going to talk about a shelf cloud that develops on the leading edge. You get this warm air that kind of lifts over the colder air that's associated with the rain. This is kind of your heads up, something's coming. That air then rises. If you have the wind shear then, that storm starts rotating. You'll have maybe significant winds with the rain here. And then if it's a supercell storm, your updraft and tornado may be back here in the back. You'll have another updraft. We'll talk about that coming up. Okay, so I kind of already talked about this a little bit with updrafts and downdrafts. I'm going to skip through this section. But essentially, when you have a little bit of wind shear, you get that updraft, that downdraft, you know how it gets kind of cool after a thunderstorm moves through? You're getting all this cold air from the top of the storm that comes down, and you get an outflow that pushes out. So that's why it gets cooler. So that is kind of a single cell storm. We're going to show you some radar examples. But then we're going to progress into multi-cells, which is those squall lines, those bow echoes. So you get significant severe weather. This is our most common type of severe weather here in Indiana. And then supercells. Well, this is the least common type of severe weather here. Supercells make up the majority of the violent, deadly tornadoes that occur in this area. So small number of storms for this area, but responsible for the roughly 80 to 90% of all fatalities in this area. So that's why we have to be concerned with these. So the single cells are short, usually non-severe, but they can have isolated severe. This is what you call your pop-up storm. This is a picture from last fall where we just had some thunderstorms developing late in the afternoon. You know, nothing too significant. But on radar, what happens, I'm going to let this play out. These storms develop, they go up, they come down, they put that outflow out. That's the blue lines you see here. And then those outflows can act to lift that air and generate new storms. So you just see a lot of different things going on. You know, just pick a storm and watch it. You know, these storms kind of dissipate. There's an outflow, then there's new storms that develop along that outflow and move off. So it's when these storms start to collapse is when they could just produce a brief microburst, which is just a very brief, small area of stronger winds. We rarely can get warnings out for these types of situations because by the time we see it on radar or you report it, by the time we get the warning out, you know, a minute later, it's done and it's over with. So it would do no good. So don't be upset if you call in a report and then we don't issue a warning. Some people call back, you know, I told you what was happening, why didn't you issue a warning? Well, it's not going to do anybody any good, okay? We've seen on radar, the storm's basically washed itself out. In very, very, very minor cases, you can get isolated weak tornadoes that develop in this situation. When two of these storms kind of merge. When storms merge, they briefly start rotating. And I have seen a couple instances where these very thin, narrow tornadoes have dropped down, but they can do a little bit of damage. So those are single cells. Here's what a microburst from one of these looks like. A buddy of mine caught this up in northern Indiana. This was only anywhere from a mile to maybe 2 miles wide at the most. And when he ended up driving through this, he encountered winds. And he said they were very strong. It went over the Warsaw, Indiana airport, actually. And they measured 55-mile-per-hour winds with it. But he said the rain was just unbelievable. He could hardly see the road. It was coming down. And they said, you know, 3 minutes later, he drove out of it, and there was nothing there. So that can also sometimes, to the untrained observer, Kind of looks like a big, large wedge tornado, doesn't it, from the distance? So we're going to talk about how to look for a rotation to distinguish that. So moving on to multi-cells now, like I said, these are the squall lines, those bow-echo type storms that develop. You have multiple updrafts and downdrafts. You have that speed shear that separates them. So these can continue over long periods of time. You might hear terms such as MCC or MCS. That stands for mesoscale convective complex or mesoscale convective system. Those are terms we throw around in the meteorology world. What that just means, it's a very, very large area. So an MCS, I think, is roughly the size of the state of Iowa. Okay, it's just a very large complex. These tend to form at night and produce a lot of severe weather early and then overnight heavy rains and flood. We get those quite a bit here in Indiana in the summertime. They develop upstream in Iowa during the day and then they roll across here at night. And derecho, we'll talk about derechos coming up. So here's kind of the schematic of what these squall lines. I talked about the shelf cloud. That's what a shelf cloud is going to look like. That's going to be out here on this leading edge. And I tell my buddies, I say this is an idiot cloud. When we're out on the golf course and I say we need to get out of here, and they're like, why? I'm like, because you'll be an idiot if you stay here. That's no joke. That's Mother Nature's way of saying something's coming. It will often be very dark. Behind here, sometimes a real just deep blue color from all the rain and hail that's falling. But that shelf cloud will move away from the rain. So I want you to remember that. Shelf clouds move away from the rain. They will just continue to move out ahead. So you may actually, in some cases, have winds associated with a shelf cloud, and it may be a good 5, even 10 miles out ahead of the reflectivity you're seeing on radar. So if you're watching radar, you're watching these storms, and you're like, okay, I think it's going to be 20 minutes before that gets here. Well, if you see a very fine, thin blue line out ahead of that line, that's probably where your shelf cloud's going to be, and that's going to be your first gust of wind. Okay, so don't get fixated necessarily on the radar where all that rain and reflectivity is. You're going to have to be aware if there's a shelf cloud, and you'll see this puppy coming well ahead of the storms. So here's what's going on. You're getting that cold rain that comes down, and it's racing out ahead of the storms. So it's lifting that warm air up over top of it, and this warm air condenses and forms a cloud. So sometimes it's just a shelf-looking cloud that's coming at you. But if this process is going very quickly, you'll start smoothing this cloud, and it will actually start looking like a rolling pin coming at you. I've experienced that once. I was about 10 years old. It scared the crap out of me. I didn't know what the heck was coming at me. I thought I was literally going to die, and I think that's one thing that led me into meteorology. But literally, it will just look ominous as it could be. Now, the cloud itself does not necessarily mean severe weather. It just means that's the leading gust front. The winds may be calm ahead of it, but right as that gets over top of you, the winds will start to increase and increase significantly. So whether or not it's severe or not, that depends on if a warning's out. But again, that is your heads up that the leading edge of the storm is getting close to you. Here's some different examples of what those shelf clouds look like. Very ominous. So if you're standing here like this guy and you see that coming, I'd be running for the trucks at this point, okay? Very dark, the heavy rain, you're gonna have lightning. The lightning can come out ahead of this, so you're not free by any means from the lightning. And then just another example of what it looks like. So here's the kind of high-end version of these storms. This is the derecho from June 2012. How many of you remember that? It was more the west, or east central part of the state and up north. This storm developed up in Illinois in the mid-morning, late morning hours, moved off the east coast at midnight. So that's basically about a 12 to 13 hour loop. You can just see how it expands. So you're getting along this line, these bowing segments, you can see. So the whole line bows, but we're looking at smaller bowing segments. So that's a squall line, and 92 mile per hour wind gusts measured in Fort Wayne, Indiana. So that's equal to an EF2 tornado, okay? Very strong winds. So be ready for those. Now supercells, as I mentioned, a little bit more of the rare event, but the most significant event. So this is where you're getting a rotating updraft, the storm's rotating. Your shelf cloud, if this was moving from left to right, your shelf cloud would be over here with the leading edge of the storm. Then this rain and hail you're going to get, it's going to become very heavy. But right before the updraft, things may quiet down. The rain and hail may end. We call this the bear's cage. You don't want to be in the bear's cage. But this updraft is so strong, it's keeping all the rain and hail up in the storm. So it can't fall out because the air is keeping it up. And it's rotating, so it's like water going down a drain. It starts spinning faster and faster and faster. So the stronger this updraft, then you get this rotation. Eventually you're going to get a lowering and a wall cloud and eventually a tornado. So that's going to be kind of on the backside of these supercell storms. Here's what it looks like for you if you're observing one. This whole part, this is your updraft, that would be rotating. You can see the dark area of rain here. These wall clouds will tend to point towards the rain because you're having a downdraft, and as the updraft starts to pick that rain up, you'll form a cloud that kind of points back a lot of times towards the rain. So these supercells, we categorize them in two different kinds, classic and high precipitation. We mention this because when they first develop, the classic, you'll be able to see if you're in the right position, the tornado. It'll be very clear. This is how we get really good video of these tornadoes. But as the storm matures and that circulation continues, that hook echo really gets wound up. A lot of this rain gets wrapped around the storm, and it gets wrapped around the tornado. So we call that a tornado wrapped, or a rain wrapped tornado. You won't be able to see it. And this is when a lot of times, unfortunately, spotters get too close, they don't know what's going on, and there's a tornado inside there. So you don't want to be that close because of that event. So these wall clouds, like I mentioned, you'll have a little bit of pointing back towards where the rain, it slopes back towards the rain. So here's an example. We call this a rain foot. Kind of looks like a foot right there. So you're getting a downdraft, the rain cooled air, it hits the ground, and then the updraft starts to pull it in, and suck it in. And that starts to form this cloud again that lowers back this way. So this whole thing's going to be rotating. You're going to see rotation here. And you're going to want to be watching the ground for any movement. That's when you know you have a tornado, is if you see any kind of debris being disturbed on the ground and lifted up. You don't have to have a nice funnel cloud that you see to have a tornado. Just another example, there's all your rain back there, and it's leading towards it. And then I'm going to actually put this into motion. So here's a nice video. I'll get my cursor on it. So you're observing this, you're seeing these clouds moving from your left to right, but then you notice in the background, it's moving from your right to left. So there's your rotation, very broad rotation. Here's your wall cloud. You see that distinct lowering? Now watch what's happening here. You see this cloud forming? There's your rain starting to be pulled up. And that's just as that air, that moist air starts to get pulled up, it cools and it forms a cloud. So again, broad rotation, there's your wall cloud, maybe a brief funnel there. So you want to be focused on the ground, okay? Your eyes are always going to want to be drawn up here because it's just so impressive. But your job is to look, okay, anything being disturbed on the ground. If you see that, it's a tornado. And then this will just continue on in a lot of cases. These may spin very quickly. It may be more in slow motion. Each storm is different. You're probably not going to have this great a view and not going to have storms this stationary around here. They are going to be moving. On days when we get those supercells, a lot of times storm motion is maybe 40, 50, even 60 miles per hour. So those things are going to be flying. But this is just an ideal situation that, so you get an idea of what you're going to be looking at when you're out spotting. Okay, so I'm going to quiz you here real quick. So this cloud that you see here is moving towards you. Shelf cloud or wall cloud?
Yeah.
Very good, yes, shelf cloud. That was taken from our camera on our radar at the Weather Service office overlooking the airport. So, I'd be heading inside right about now and getting to a safe place. Okay, shelf cloud or wall cloud? Say again, come on. Wall cloud, yeah. So here's your rain. You can kind of see a little bit of striation or rotation up there, and you got a little bit of a tail pointing back here. So yeah, wall cloud. How about this one? Shelf, very good. We're trying to fool you a little bit. This was coming at you. See these little fingers? We call those scud clouds. People a lot of times want to misidentify those as funnel clouds or even tornadoes, because sometimes those will actually look like they're touching the ground. But you want to look for, you know, this may be rotating like a rolling pin, like I mentioned. That's not important. But if these are rotating vertically, then you might have a developing tornado on the leading edge. That does happen in some cases. But most of the time, these are actually going to be kind of lifting upwards, and that gets mistaken for a rotation. But these are just scud clouds, low hanging. They're just scud. That's where they get their name literally from doing that. Okay, how about this one? Little hint that's coming at you. Shelf, very good. Again, kind of that curve is meant to trick you a little bit. It's a good job. It's coming at you very dark behind it, so it's moving away from the rain. How about this one? Wall, very good. Good job, yeah. And this one? Wall, yeah. There's that rain foot. Those are always impressive. So it's actually coming in here, starting to get here. So this may be your development of a funnel cloud. So wall clouds and funnel clouds, what's the difference? Where is the difference? I honestly don't have a good answer for you. A funnel cloud will tend, because it's rotating quicker, will tend to have smooth sides because of that rotation. But you could say, okay, maybe this is a developing funnel through here. Sometimes it's not going to be classic and easy, but as it develops and matures, a funnel will usually become more distinctive. But again, is this a tornado or a funnel cloud? I'm looking down here, or is anything being picked up, or the trees being ripped apart, or anything at this point to tell if it's an actual tornado from a funnel cloud. So we want to know anytime you see a wall cloud or a funnel cloud, you look for that isolated lowering, and remember the funnel cloud does not have anything touching the ground whatsoever. So we'll transition quickly into tornadoes here, and then we'll take a brief break. But this is what I think is the most violent tornado I've ever seen. I apologize, there's a little bit of language at times, and chasers kind of get caught up in the moment. So very strong supercell. So we have rotating updraft with this storm. See the debris already flying. Focus in right now. Look at these winds coming into the storm. Look how strong that inflow is. We're probably talking at least 70, 80, 90 miles an hour if that's strong. Winds coming in. So you're getting these winds coming in, you're hitting buildings, then you're also getting the pressure, which is lifting, the uplift with these storms. So structures just can't handle all those forces hitting them. Then your debris gets lifted up. And, you know, that's a huge piece of probably a metal shed or metal roofing. There's your power lines. Watch those power poles just get ripped and pulled back.
Oh no, there's the line.
Just an incredibly violent tornado.
Oh my God. Oh my God, look at that.
Then if you're out there,
Oh my God.
stay away. I mean, you're fine at this distance. What are you think you're doing here? You know, they're going around the power lines, they're going over a hill. I don't understand what they're doing there. So again, stay safe, be smart, but just, you know, that really hits home how powerful these tornadoes can be. So we want to know anytime you're seeing tornadoes or the funnel clouds. You know, kind of already covered all of this pretty good. So with that, we're going to take a quick 10-minute break. So it's 10:06, so let's be back here at 10:15. All right, we'll go ahead and get started here. For those of you still fill out forms, that's fine. So now we're going to get a little bit more into meteorology. We're going to give you a little bit of advanced meteorology here. This has kind of been requested for some of you people that have come to this. Yours out here, you kind of want to see a little bit more. So I'm not going to get too technical, but show you some fun things that we look at in the Weather Service office. And then hopefully we can get you out of here so you can go get some of that fish and enjoy the rest of the day. So we're going to talk a little bit about Indiana tornado climatology. I've kind of covered that a little bit. But in this section, what we're going to try and do is tie how important spotters have been on a couple of events that have impacted Indiana. So we're going to talk about a typical tornado outbreak, November 17th, 2013. Now I say typical tornado event, but it's in November. People are like, tornadoes don't happen around here in November. Well, yeah, they do. Yes, they do. And especially over the last 20 years, we have seen more and more tornado events in the fall. We're going to talk about an atypical outbreak, August 24th, and then just briefly June 15th. But August 24th is a great example of how we weren't expecting tornadoes on that day, and things changed instantly, and spotters played a critical role in helping us on that. So 70% of all of our tornadoes in Indiana are either EF0 or EF1. So the EF scale is how we rank tornadoes. I'm sure you've all heard of that. So 0 is the lowest or the weakest. The wind speeds are the weakest. That's why they're called weak. It's associated with their wind speeds. And then a 5 is the strongest. So 70% fall into this EF0 and EF1 category. And really, less than 1% of all fatalities associated with tornadoes occurred from EF0s and 1s. So, on most tornado days, if you do everything you're supposed to, you're inside, you're away from windows, you are going to be safe from tornadoes. These tend to rip siding off homes, break windows, shingles off of roofs, bring trees down, those kinds of things. So about 2% of all of our tornadoes are considered violent, EF4s and 5s. We'll consider this. Of the 5s, we've only had 3 in Indiana, and all 3 occurred on the same day back in 1974 in southeast Indiana. Okay? So you can take 5s, at least for right now, out of the equation. Very, very, very rare for Indiana. Not to say we won't see one, but very rare. So we really should be focused on the EF2s, 3s, and 4s, because that's what's going to make up about 30% of our tornadoes, and honestly, 95% or more of our fatalities with tornadoes. The majority of those occur with those supercell thunderstorms. The 2s and 3s can be associated with the squall lines, but it's those supercells that produce those higher winds. So that's the breakdown. The last time we saw an EF4 in Indiana was back in 2012 in Henryville. So we are kind of overdue for something on that stronger end, unfortunately. And there are some similarities in the jet stream this winter to 2012. Now, I'm not saying by any means it's going to be a 2012, but 2012 is a very active severe weather season in the Midwest. So we're a little concerned with what we're seeing in the jet stream, that we might have an active spring and early summer coming up. So continue to be aware and use the products we've talked about today in the event that things like that happen. Tornadoes in Indiana have occurred in every single month. And you notice our peak here, we're getting into March now, so we really start to ramp up from February to March, March to April, and then our peak is in June in Indiana for tornadoes. Then we start to drop off a little bit, but notice this secondary peak here in the fall. So we do have a secondary season, we're all very familiar with that. We get the wind shear in the fall with those fall storms that bring a lot of heavy rain and winds as we transition seasons. But we usually don't get those dew points up into the 60s that I talked about. But in recent years, we have seen that. So we get that instability with that wind shear, and those wind shear is what really drives those stronger tornadoes. So we've seen that occurring in fall, dating back really kind of starting in the early 2000s. So as meteorologists, we look at the upper levels. So we launched weather balloons. Okay, so everybody knows weather balloon goes up, it has instruments on it. It measures temperature, humidity, dew points, and wind speed and direction with height. So that's how we try and determine what's going to happen. So for an ideal storm, at about 5,000 feet, we look for these sharp troughs in the atmosphere. These are areas of low pressure. So when you see these lines that are real sharp, that allows good air to come up from the Gulf of Mexico, strong winds in the low levels. Then we go up to the jet stream level. And again, you see these kinks these lines, that area of low pressure. But this blue outline is where the jet stream lies. So that's the area of strong winds coming in. So we like to see this little kind of dip. And then you see this green? That's called a jet stream. So that's an area of stronger winds embedded in the jet stream itself. So think of the jet stream as a river. And think of these jet streaks as you and your boat going down the river. Okay, you can go faster than the flow of the river, right? That's what's happening in the jet stream. So these streaks are what we're looking for to set off the motion to get storms firing. So we want to be kind of where this starts to curve up. We want to be in this kind of left area here. That really just primes the atmosphere, especially when everything else below it is set. Now, if we go up even higher, 30 to 40,000 feet in the atmosphere, the very top of what we call the troposphere, there's even stronger winds up there, the very top of the jet stream. We want to look for what we call diffluence. We want that jet stream to kind of be splitting. And what this does, it's the atmosphere. If I go back to my boiling water analogy, this is the fan on top of your stove that you turn on. And you know when you turn that on and it starts pulling the steam up, that's what the jet stream is actually doing in the top of the atmosphere. So now you're increasing the air. You're saying, okay, the atmosphere is primed for all this air to rise. And then we want to see our low pressure track just off to our northwest, because then that allows all the moisture to feed up into Indiana. So you often hear in the wintertime, storm track's important for where snow's going to fall. Storm track is just as important in spring with severe weather to make sure we get into that, what we call warm and moist sector. So November 17, 2013, that was the setup. Everything was perfect. So here's some pictures. This was the Washington, Illinois tornado. Very, very destructive tornado moved through Illinois, and then eventually these storms moved into Indiana. The blue here, these are all the severe thunderstorm watches, or warnings, I'm sorry, that were issued across the Midwest. The red, all tornado warnings that were issued. Pretty much everybody at some point on this day was under a severe thunderstorm watch, and then a large number under tornado, or warnings, I'm sorry, the tornado warnings. So there were 149 tornado warnings, 213 severe thunderstorm warnings on this particular day. So here is the low pressure. It tracked up through Illinois and into Michigan. So these greens, that's those dew points, that moist air that comes up. So the winds ahead of this were southeast. And then think about those maps I showed you as we went up. They were southwest, west, and then northwest. So we had that turning with height. And we just had all this incredible moisture coming up and feeding ahead of this line. So here's even more detail of the maps. This purple is that jet streak as it was coming right towards Indiana. So again, we're in the perfect setup. And then when we get the data back from these weather balloons, this is what we're looking at. So this is called an upper level sounding. And this shows the balloon. The red line is temperature as you go up in the atmosphere. The green line is the moisture. But what I want to focus on are the winds. We had south winds near the surface of about 20 miles per hour. But as we get up to 5,000 feet, they were 50 to 55 miles per hour. And then even higher up, they were closer to 80 to 90 miles per hour. So we had this turning in the low levels, and then they kind of straightened out. But this is a classic setup to get storms rotating, coupled with what we're seeing with the temperature and the moisture over here. So here's how the day developed. We started out with classic supercells. So this is a pretty common occurrence, is when storms develop with that profile for tornadoes, you get these classic supercells. So when you look over here in Illinois, you see more individual storms. Then that wrapping occurs we talked about. So they kind of get into these high precipitation supercells, so they become rain wrapped. But then as time goes on, now look what happens. You've got a line over here. So all these individual storms start merging together, and you transition through these different storm types that we talked about in one event. So we might be talking classic supercells as the event develops in the afternoon, but over on this side of the state by the evening, we think it may transition to squall lines, which means the tornado threat would go down, but the strong wind threat would go up. So you have to be aware of changing conditions as we go through these storm modes that I've talked about through the day. So that's what happened. Washington, Illinois had the tornadoes. The western part of the state had tornadoes, but then the eastern part had more wind damage from this event. So here's where the tornadoes occurred, and again, you can see they're kind of confined to this northwest area where a couple of those individual supercells tracked. And then there was another supercell that tracked down here. But notice the tornado tracks in because it formed all those lines. And if we had wind damage plotted up, you would see more wind damage on this side of the state. So a lot going on, 30 tornadoes from this event alone in Indiana. So the largest tornado outbreak in November for the state. It was the second largest tornado day in the history of the state in November, mid-November. Pretty impressive. Central Indiana, the area that Indianapolis covered, we had 16 tornadoes. And you can see the majority of them were the 0s, 1s, and 2s, but there was the one EF3 tornado in there that tracked up near Lafayette and produced pretty significant damage to a warehouse there. Again, this is why I say large span roofs don't work. Essentially, that metal that they use, especially in the warehouses, once you get up to a strong EF2 to EF3 tornado, that stuff just starts being twisted. So usually there are small rooms inside here with smaller compact walls, restrooms, that kind of area. With the EF3s, in a lot of these cases, I have seen those rooms have remained intact with these tornadoes. So that's going to be your best option. But if you're out in the warehouse park, it is not going to be good if you take a direct hit from this. Okay, so now we kind of transition to an atypical outbreak. This will go to the August 24th, 2016 event. How many of you remember this event? Probably not down here too many of you. Kokomo, Indiana. Kokomo just got hammered on this particular day. So in the morning, our mid and upper level dynamics, those jet streams we talked about, were much weaker. We weren't really expecting tornadoes on this day. We thought there could be afternoon severe thunderstorms with a wind threat. But tornadoes were not even something we were considering at 5, 6, 7 in the morning. So we need some other factors to actually change the atmosphere. I'm going to show you what happens that actually can do that very quickly. More often than not, those setups don't come together like this to produce a tornado outbreak. But we have to be ready for it. So when they do come together, you end up with an EF3 tornado. That was from up near Fort Wayne. Thanks to drone footage, you can see the track that went through here. And there was a farmstead there that was basically completely demolished. So this got rated as at the very top of the EF3 tornado. Gentleman I worked with that did the survey on that farm, he actually wanted to rate it as an EF4 tornado because we rate it based on the damage, and the damage we see equates to certain wind speeds that can do that damage. There was an old combine in there, not the newer ones, but kind of the old ones from back like in the 40s and 50s, kind of the smaller, more compact combines. You could barely tell it was a combine. It was just wrapped and twisted like you wouldn't believe. But unfortunately, we can't rate that. We don't have what we call a damage indicator. We need buildings or things that we have studied and we know how they can withstand the forces of the winds. So we couldn't actually elevate it, but we felt like the winds had to be stronger to do that to that kind of a piece of equipment. So that was just an interesting thing that occurred with that. But the system started as one of those MCSs I talked about, the mesoscale convective system. The system developed at night, and all these blue dots are straight line wind damage that occurred. So we had straight line wind damage all the way up into Illinois, but then all of a sudden, all the damage reports turned into tornado reports after a brief break here. So what happened in the atmosphere? Initially, forecasters thought this was going to just redevelop and be a wind threat over us. But what happened, we had this area of low pressure that actually developed out of those nighttime storms. They actually spun up their own little mini low pressure system. We had a warm front that was lifting north, and the combination of those two things led to this development. So these maps are a little bit more difficult to see, but you can see that little bit of curvature I talked about, it's not near as significant as it was in that previous event, right? So the upper atmosphere really by itself, we weren't expecting that. There was a little bit of turning in the winds here, but the winds were a lot less in the low levels. They weren't near as strong as that previous event. So we thought this might be enough to get those storms, like I showed you early in the presentation, rotating, but they just weren't strong enough to get the circulation down to the ground. So the winds much higher up were stronger, so we thought, okay, there's a wind threat there if we can get thunderstorms developing. But what happened? We call this a mesoscale convective vortex. Watch here in Illinois, you see that little twist in the satellite right through there? That wasn't supposed to be there. None of our models had that. We weren't expecting that. That nighttime system that developed in Iowa, this is right after sunrise. That satellite caught this. This was a leftover circulation. As those storms died out in the morning, they had gotten the air spinning. And the winds associated with this through Illinois, all the way up with those weather balloons, the morning weather balloons caught it, winds were much, much stronger than what we were expecting. So now that turning with height that we didn't think would be significant, now those winds are 20 to 30 miles per hour stronger. Suddenly now we're worried about supercell thunderstorms at 7 a.m. for 1 or 2 o'clock in the afternoon. So we've already put the hazardous weather outlook out that said isolated severe thunderstorms, wind damage, no tornadoes were even mentioned. Our forecasters recognized this about 9 or 10 in the morning, and they updated that HWO. We started making phone calls and saying, hey, we have a tornado threat this afternoon. We kind of need to be changing our thinking. So that's how quick something like that can spin up from other storms and change the whole dynamic. So as that feature then moves into Indiana, you can see these kind of brighter explosions. Those are the tops of thunderstorms starting to develop. And then you see this cluster kind of move through here. Here's another cluster, and then another cluster here moves through. All of these were kind of developing right on top of Howard County and Kokomo, Indiana. So here's the radar loop. There's all the tornado warnings that were issued. What is amazing about this event, for tornadoes not being expected more than a couple hours ahead of time, forecasters recognized it. Spotters started calling in the reports of wall clouds, funnel clouds, and tornadoes. Every single tornado on this day was warned by a warning. We don't even get that on days where we know these are happening. So that was pretty impressive. There was no fatalities anywhere associated with this. There were a few injuries, unfortunately, but nothing serious. This is the one that actually collapsed the Starbucks in Kokomo. If you've seen that video, you can get on YouTube and see that. But just notice Kokomo was just under tornado warning after tornado warning. That is rare for that to happen. So I'll let this play through one more time. And here's Howard County. So initially, as these storms developed, there was no watch out. Storm Prediction Center, they also recognized this, and so then they quickly got a watch out. So this is another event, or a event, where you may not have a lot of lead time with that watch coming out because the atmosphere is changing. But again, just keep your eye here. So there's the first tornado warning for Howard County. So that cell moves off, kind of developed backwards. So you might think, okay, they're in the clear. Well, then here comes another line with that spin in the atmosphere. And now we have these cells that are rotating and producing tornadoes. Spotters are calling in. So now we've got an issue for all these circulations. So there, Howard County again goes under more tornado warnings. And then that line turns east-west and more spinning storms start developing. So just an unbelievable day where we weren't really expecting it to be that active. So here is a really good video from some spotters that got out that day. So this is near Fort Wayne, so that's kind of the up in the northeast part of the state as the tornado was starting to develop. There's your wall cloud. Obviously you have your tornado. You can't see what's going on behind those trees, but again, it looked like it was close to being on the ground, but you can't make the assumption. And this is a little bit later, just a massive tornado. They're really a little too close. They think they're fine, and you think they're fine. But if these poles start going down, all those power lines are going to come down on top of them. So fortunately, that didn't happen. So you see a lot of debris being thrown around, but watch the bottom here. You're going to see individual little funnels here spinning through. So can you see those? Those vortices. There's several actual funnels and tornadoes embedded in the larger tornado. A lot of circulations you can see. So how many of you have the vacuums at home with the multi-vortice suction? Okay, that's where it comes from. When you get that, you're getting more lift in the atmosphere. You're creating more damage. So even though that's one tornado, you can have these multiple vortices embedded in it, which creates a lot of destruction, and that's what's happened there. So that has really become a rain rack. That was a lot of rain on the outside, and that's why it's very difficult to see those smaller vortices inside the rain. So in this event, we had 24 tornadoes across Indiana, Ohio, and even into Ontario. They were primarily in that 0 to 2 range, but we did have 2 of the stronger EF3s. That was Kokomo and then Woodburn, Indiana, which is just outside Fort Wayne. First tornado at 2:38 in the afternoon. The final one was 9:06 in the evening. You know, just an unbelievable long duration tornado event. So it was one of the largest outbreaks for August, and it doubled any prior daily tornado record of August and September combined anywhere across Indiana and Ohio. So just unbelievable. The Indianapolis office issued a tornado emergency for Kokomo. This is more meant for our larger cities, more populated areas. But when we see a tornado that's heading towards a populated area and our spotters have confirmed, yes, it's there, we can issue a tornado emergency that basically says, hey, spotters have said there's a tornado, it's a large tornado, it's going right for the metropolitan area, get to cover now. Okay? I think Indianapolis has only issued one of these. That was this one. That's how rare they are. So that's the top end. You're in a life-threatening situation. Flying debris may be deadly to those caught without shelter. Mobile homes will be destroyed. Considerable damage to homes, businesses, and vehicles is likely. Complete destruction is possible. So more than likely, this would be something that we would issue for Greensburg itself. Not necessarily for a smaller town, but it's just something for those higher population areas. So if you hear a tornado emergency and you're in that area, it's going to be bad. So take that seriously. Okay, then we're just going to quickly run through this one. This is another kind of atypical event, June 15, 2019. So this was a combination of wind and tornadoes. So we were outlooked at a slight risk by the Storm Prediction Center, and most of the reports fell in that area, so the outlooks were pretty good. But here is Rush County. There was a tornado that was caught on a security camera. Did quite a bit of damage to some farm buildings. But again, not a lot of turning in the low levels, not a lot of stronger winds. So we weren't really set up for a big tornado outbreak. We weren't really considering it. But here's the radar loop. And again, forecasters initially had severe thunderstorms warnings out, but they saw strong rotation and spotters started calling in, hey, we've got wall clouds, we've got funnel clouds. We quickly transitioned to just issuing tornado warnings in this case. So hopefully I've hammered that home enough how important you guys are and how you can change how our warnings are dictated based on what we're seeing. So this ended up being the largest tornado outbreak in the area since 2013 event. 7 tornadoes across the central part of the state, 10 total, and EF2 tornadoes in Greene, Monroe, and Rush counties. That climatology, obviously from south to north, tornadoes are, climatologically are greater in the south because you have better chances of getting that moisture up here. So the numbers are a little bit skewed when we look at that climatology, but certainly south of Interstate 70, you have greater odds of seeing more tornadoes compared to the northern part of the state. So just a few pictures. This was the Beech Grove school that was hit over there on the left. Ellettsville, Owen County, a lot of tree damage with this event, impacted a lot of rural areas. So again, just to reemphasize why you're important, you help us make better informed warning decisions. We can't do this without you. and quality. And please continue to get trained. Don't think just because you're here today, you're set for life, okay? There are a lot of new advances in the science. A lot of the supercells, what we know about those, we're actually finding out we may have to start teaching a little bit different as we learn more by the scientific and the research community. So take this training often. And again, you're helping emergency managers and first responders, and you're helping save lives. So timely spotter reports helped in all of these events I've showed you today. So kind of to start winding down here, if you're really interested in weather and you really want to do more, this CocoRAS is a great program. This is a citizen science program where you measure precipitation, rain, hail, and snow, and you report to a website every morning. We take this information, and that helps us get flood warnings out across the area. It helps us know where the heaviest snow fell. Do we need to adjust where our winter weather advisory or warnings are at based on snowfall reports? And then your data is tracked. This is done all across the United States, Canada, even the Bahamas and Puerto Rico. So it's just a great additional tool to help do weather reporting. If you want to see what kind of precipitation's falling, whether it's rain or snow or hail or sleet, this IMPing app that you can get and download on your phone, you can you call it up, you say, okay, it's raining, and you hit submit, and it sends your location to a database, and then it gets plotted on a map across the United States with the type of precipitation report you put in. So what you're seeing here is just a loop of people that have reported the type of precipitation that they've seen. So we can zoom right into Indiana, and it's just a cool way to get a quick idea of what you're seeing and where. So if any of you have radar scope, any of you have radar scope on your phones? A few of you, that's a great radar app. Not that I can promote any particular company, but that IMPing is actually built right into it. It uses GPS on your phone, and you can look at radar and say, I'm getting rain, and submit your report. If you want additional training, if you've really liked what you've had today, you want to go more in depth to it, Skywarn Spotter training page here, and then Spotter Network has a great training program. We have links to all the information we talked about. We don't give away as many handouts because of printing costs now. There is a handout in the back with QRC code. Again, you can just scan that with your phone, or you can just go to weather.gov/IND/spotter, and a lot of this information is on there, links to other websites, things we've talked about. You can get it all there, everything you want. If there's something not on there that you think would be useful, send us an email. We'll add it, okay? As long as they let us link to something, we will put it on there for you so everything is in one place. Okay, so again, during the biggest events, we'll have 1 or 2 individuals dedicated in our office to receiving your reports and social media. And the bigger events, that number even jumps up to 3 or 4 people. So we have a lot of people in our office taking reports. They're very important to us. You can report through Facebook and Twitter. Okay, just put in there you're a trained spotter, and pictures and video are fantastic. Okay, that just backs up everything you're saying. If you can send that to us, that's great. The phone number there. We do have a link on our website where you can actually just fill out a form and submit it. That comes right into our computer system, so you get that right off our front page. And then the links to the IMPing. Email, if it's after the event, a day or 2, and you notice something or hear of something, shoot us an email with the picture of the location of the damage. Like I said before, we use that to verify warnings, and we want that information. And then amateur radio, thanks to all of you that are amateur radio operators. I've made it a goal within the next 24 months. I'm going to get my license now that I'm a warning coordination meteorologist. I think it's pretty cool, especially for the young people. This is a great hobby to get into and really make a difference. So be thinking about doing that if you haven't already. And then finally, I'm going to wrap it up with a program we call Weather Ready Nation Ambassadors. If you work at a school or a business or an organization and you're really responsible for your employees, you take weather safety seriously, and you do a lot of training, sign up for our ambassador program. So it's weather.gov/WRN. It just takes not even 2 minutes to fill out the form. But you'll get a nice welcome letter. You'll get this logo that you put on your organization's website to say that you are helping promote weather safety, you're helping educate the public and your workers and keeping them safe. But your business then, or your organization, or your school, for Central Indiana, we send out a morning email briefing on weather and the significant hazards we're expecting over the next 48 hours. So if you have a safety officer at your organization, they can get this every morning at 6 a.m. in their inbox and say, okay, we have nothing to worry about, or, oh, I need to be worried about the system coming in on Monday, make sure our workers are safe. So if you're doing that, get recognized for it and kind of get that weather awareness update. So with that, I've kept it under 2 hours, which is pretty good for me. And I want to take any questions here before you go. Anything we've talked about today or anything we didn't cover that you're curious about or want to know about?
I got a question.
Yes.
Just a few minutes ago, you was talking about, I believe, of June of 19.
Yeah.
Is that correct?
Yes.
So if I remember correctly, that's two fronts went through that day, north of Jackson to the end of Bartholomew over in this direction.
Okay.
And the second one, I think, come through Jackson County. Do you guys have a website where you follow up on a day's event like that to where, or do we just got to rely on listening to the news?
No, good question. We do. So what will happen, we will try, mainly for the bigger events, so if you have an isolated event, we won't do it. But we will try and do a review of every event. And on our front page of our website, weather.gov/IND, up at the top it says news headlines. And we try within a day or two to get a headline up there as a review of the storm, what happened. And we'll review the damage as well as a little bit of the meteorology of what went into it. So look for it there. What we used to do is after we wrote those stories, we would archive them, and we have a weather history page. Well, we have some issues with storage space on the National Weather Service servers. So for right now, we can't archive those stories. So they'll be there generally for a week or so, and then for right now, they'll disappear. But if you ever need that for anything or have questions, you can send our webmaster an email, and we can kind of send you the hidden link for that. But I'm being told within the next year, they're going to increase our server capacity so we can get those archived weather stories back on there, because everybody loves those. And you know, we've had them for the blizzard of '78. We have a real nice write-up for that, but we had to take it off because it took up too much storage space on our hard drive. So look for that on our webpage. We will do that for the bigger events. And I think we did have one for that June 19 event.
It was just interesting with all the information that day. There was, you know, tons of, this was a tornado, this wasn't, this
Yeah.
is, it's occurring, so.
Yeah. And afterwards, you know, the Weather Service comes out if we think it might have been a tornado. And anytime there's damage, people always think it's a tornado. I can tell you, I have seen damage from straight line winds that is unbelievable. And people are like, well, straight line winds can't do this. How many of you have heard of hurricanes? Okay. Hurricanes pretty much straight line winds. You know, they're going around a big circle, but that is straight line winds with tornadoes embedded. So straight line winds, when you get up again above 70 miles per hour, and especially the derechos with 90 to 100 miles per hour winds, that is going to look like a tornado came through. And those straight line winds are on a much larger area. You know, your tornado is pretty concentrated. Straight line winds are over a large area, so you're going to have much more damage and significant damage from those higher consumption.
Yeah, it'll lift a 38-foot camper about 4 foot high and dump it over on the side.
Yes. Once the air gets underneath anything, it's going to lift and then roll and turn.
Yeah.
Yes, sir.
When do you launch most of those weather balloons from school? Indianapolis?
Yeah, good question. No. He wants to know where we launch weather balloons. So certain offices around the country are spaced out to launch them. So Central Illinois, Lincoln, Illinois is the nearest one. Well, for you guys, actually, Cincinnati. Wilmington, Ohio is the nearest. To the west, it's Lincoln, Illinois. Detroit does it. Nashville does it. So what they do because of cost, they try and spread them out across the United States. So not every Weather Service office does it. So that then becomes, you're kind of assuming what's happening between those stations. And that's where sometimes the models can't pick it up. So the event with that circulation, fortunately the Lincoln, Illinois balloon caught the increased winds there. But had we not launched that balloon, we probably wouldn't have detected those stronger winds, and we probably would have been caught off guard by that. Yeah, in the back.
You said you were monitoring the airstream because it was similar to the 2012 pattern.
Yeah.
How long would that last?
That's an unknown we don't know. And that's kind of what we're looking at. And it's just been a few things, but the jet stream this winter has been very, very strong. But it's been locked up well to the north. That's what's kept the cold air. How many of you have heard of the polar vortex? I love talking about the polar vortex, okay? The polar vortex has been as strong as it has ever been this winter. Now, does that shock everybody? When the polar vortex is weak, that's when we get the cold air. When people start talking about, you know who I mean by people, about the polar vortex impacting our weather, it's actually in a very weak state. So think about, I like analogies if you can't tell. Remember the old tops that you spun on the table? Okay, you know when it's moving really fast, it's vertical? That's what the polar vortex has been. That locks the jet stream up. It spins very fast. But when that top starts to wobble, that's what the polar vortex is doing. The jet stream actually starts to weaken, and that polar vortex then, a piece of it can wobble south, and we get cold air that comes down. So it's that weakening and wobbling that brings the very cold Arctic air. But it's a piece of the polar vortex that comes south, so then you just hear, oh, the polar vortex is bringing us cold weather. So that has been literally off the charts. We started measuring some of that back in the 1950s. And some of the things we look at in the Arctic have literally been as high as they've ever been, which has locked that cold air up to the north. But the point there that I'm getting back to is that the jet stream has been very strong. So if that jet stream continues with that strength and then starts to come south like it always does in the spring, we're very concerned with that kind of a strong wind that we could see strong storm systems. Now whether or not that impacts Indiana or Kentucky or Tennessee, we can't get that detail, but it's just something we look at, kind of our awareness now is, okay, we need to be thinking we potentially could see a big event if that does get down here. So we're looking around the globe, the northern hemisphere, studying patterns. In the wintertime, we're looking in Siberia, studying patterns over there to see if that cold air is coming south. So we're constantly monitoring a lot of different things using satellites, weather balloons, and stuff like that. Good question. Did you have one?
That was related to the weather balloon question. Is there a possibility that the Weather Service could cooperate with, like, say, universities that have meteorology programs like Ball State or Purdue or something like that to give students the opportunity to launch weather balloons as like a practical application that would be shared with the larger network?
Yeah, there actually are programs in place. We have volunteers, so we get students that come out to Weather Service offices every summer and volunteer. I just talked to one the other day, and she actually had gotten certified to launch upper balloons as a student at another Weather Service office, so she gets to do that. Some universities have their own funding. When they go out on storm chases, they launch their own balloons and teach the students how to do that. And then they actually feed that information back to the Weather Service. So we sometimes get this data from areas we normally wouldn't when they do that. So there's nothing formal in place, but certainly if you know any students who want to be involved, they can try and put in to volunteer at a Weather Service office that does that and get experience doing it. Yeah. All right, any other questions? You're all dying to get to that fish now, aren't you? Well, thank you. You've been a great audience. I hope you've learned something today. Again, make sure you just at least sign in so we know how many people were here today. And I'm happy to hang around and answer any questions you have. So, thank you.